Good morning, everyone. Do we have the clicker for the slides? Am I not?
Oh, it's probably on the table, just a second.
On the table? That's the table slide.
Send me slides back.
Sorry, folks. There we go.
Just gave me an excuse to come back up with the wine.
Have an eye on that too. Well, good morning, everyone, and I'd like to thank SWAG for allowing FM Global the opportunity to talk to you this morning, in particular Dan for his invitation a few months ago. As Craig said, I'm a group manager of field engineering for FM Global based in Melbourne, and I have two excellent field engineers based in Auckland that do our servicing throughout New Zealand. So why, indeed, is an insurance company presenting to you this morning? As Craig said, we're quite a different insurance company. We're very much a hands-on company, but we only look at property insurance and business interruption. We don't do vehicle insurance, we don't do directors' insurance, workers' compensation or accident insurance. It's purely property, contents, stock and business interruption. So it's a very focused niche market that we work in. In that market, we spend a lot of time gaining knowledge of the industries. We've become quite intimate with all the different industries we look at. We have a look at the losses that occur in the industry and try and learn from the losses and return that information back to our clients to better protect the industries we work in. As a mutual company, our policyholders are our shareholders, so we have a responsibility to all our clients to protect the value of the business, of our business, which is the value of their business. So there's a very much a vested interest in helping our clients reduce their losses. We're 175 years old, based out of the US on the East Coast, so the model we have is quite unique, but it seems to work because we're still here. Locally in the printing industry, we have, as Craig said, PMP, we look after APN, Fairfax in Australia, News Corporation on a global basis, West Australian News, and a number of smaller printers throughout the region. So we have a lot of experience. In addition, we also look after pulp and paper industries, power industries. A couple of names I throw around is Boeing and Airbus are clients of ours, IBM, Microsoft and the like. So we play in the big end of the market and we do it on a global basis. And we use that information to learn from all the industries and try to bring our loss prevention advice from what we learn. As Craig says, we take a different approach. We don't use actuaries. I think we have one in the company. He looks after our investment portfolio. Other than that, we're pretty much, it's a line ball between an engineering company that provides insurance and an insurance company that has engineers. So we have about 5,500 employees on a global basis, and more than half of those are engineers, including our senior management team. So it's a very much engineering company. The basic philosophy that FM Global takes is that the majority of losses are preventable, and to that end we have to take a risk management and a risk mitigation approach to what we do. So what we have here is a picture of our research campus that we've recently built in the last 10 years. It's based in West Gloucester, Rhode Island, and it's about 1,000 people work at our research campus, research scientists, PhDs, pyromaniacs, those sort of people. We burn things. We have natural hazards labs where we shoot pieces of 4x2 through plywood. We test toughened glass. We subject roof samples to wind upload testings for cyclones and all sorts of different things, just so we can understand exactly how they perform in a loss situation and how we can provide clients with advice on how to avoid those situations. So that information we take and we create our loss prevention data sheets, which they're available free to anyone who wants to have a look. And then for clients, we add a field engineer with those to help interpret those and have a look at their facilities. So we bring this information out to our clients and share it and try to help mitigate potential risk. The key thing here, and you'll see later on, is it's full-scale fire testing. So it's not computer modelling. It's not small-scale testing in a little cabinet in a lab somewhere. This is full-scale testing. So, and again, there's some videos coming up to protect a roll paper store. If you want to know how to protect one of those properly, then you recreate a full-size roll paper store in a burn building, which is the big rounded roof section down the back, and you set fire to it and see how it goes. It's quite a good place to go. So as a part of our training, everybody who joins the company has an opportunity to go and have a look. I've got here a couple of photographs from the day I went and had a look back in 2004. So on the left there you'll see a dust explosion. This dust explosion building, there's a little room off to the side where the guy stands and sets it off. He's probably about less than a quarter of the height of that unit there, the bunker as they call it. So they'll take various dusts, paper dusts, powder coating dusts, metal dusts, flour, starches, all those sort of things, put a quantity in, fluff it up with some air and put an ignition source in and see what happens. And that one was a powder coating plastic polymer, only about a cup full, enough to fill up half a hard hat, and they turned it out and gave it a big puff up with the compressed air and just let a little spark plug off, and that's what happened. So it was pretty impressive. They had us standing behind a bulletproof screen there, so we were okay, about 50 metres away. On the right hand side is one of our 2 full-scale burn labs. So this one in particular, we were testing plastic pallets in racks. So we use standard commodities to do our testing. As you can see, it's a long way away, but that's full-size rack, Dexian rack storage, set up in a particular way that all our tests are done. The building there has a movable roof that moves from 60 feet down to 12 feet, and it's US, so we're all in feet when we go to the research campus. And they put a sprinkler system on top that they want to test, and then they set fire to it. So you can see we're behind a wide glass screen, which is oven proof. It's basically the same as your oven door, heat proof glass, and they stand everyone up there and set fire to it. So the emissions off the building all get filtered through, and it's a zero emissions testing facility. So they have 2 large-scale burn labs, and as I found out recently talking to the research campus manager, they did over 365 tests last year, so they were doing at least one of these a day all last year. Typically they range from $50,000 to $200,000 a test. But the value it gives us in understanding how to put fires out properly is well worth the investment. So in our 175-year history, we have a look at losses in every particular industry. We have a look at how often they happen, what the magnitude of the loss is, the dollars it costs, and for most losses we send an engineer out with our claims adjuster and we try to understand what it was that happened. Can we learn anything from it? Have we missed something in the past? Do we need to go back and do a bit more research? And we put it into our data sheets. What it also does is when our field engineers come out to site, is they get this little pie chart and it tells us where we need to focus our attention when we go out on site. So for the printing industry, when we come out to APN and PMP and the like, we'll come out with this in mind, and we'll focus on the areas where, as an industry, we're seeing the biggest losses. If I was to be standing up here talking to Steve's team from Norski, we'd have a different graph and we'd be focusing on completely different things at their facility as we would for a warehouse or an airport or a big vehicle manufacturing company. So with that in mind, we'll just touch on some of the common loss drivers in the printing industry. Number one, and this is typical of most locations we go to, the number one loss driver is natural hazards. So we're talking earthquake, flood, windstorm, etc. Hail is another big one. Locally here, it's flood. Flood is an exposure everywhere. The big thing about flood for insurance companies is aggregation. When you have a flood, it doesn't just flood one person's facility. Like a fire typically only burns down one factory. Floods tend to flood whole areas, as they saw in New Orleans and the stuff. Creates a lot of damage and it creates a high number of losses and a lot of dollars in cost. So earthquakes is another one, as recent history has demonstrated. The key thing is typically a facility is where it is. If you're building a new one, you can have a look at whether you're in a flood exposed zone, whether you're in an earthquake zone or a windstorm zone. If you're already there, then it's just a matter of understanding where you are, what your potential hazards are, and what you can do to mitigate that. So understanding that you're in a flood zone is a good thing. Chances are your insurance company have already figured that out and you're paying accordingly in your policy, but it's good to know that someday you might have several feet of water, several metres of water coming through your front door, and understanding what it is it's going to cover and how you get around that and how you get back up and running as quickly as possible. Next one we have is combustible dusts. Typically in the printing industry they come from your cutting, slitting, folding operations where you're kicking up a little bit of dust. So when we come out on site we have a look at those operations. In particular we'll focus on the cutting areas. We'll have a look at how you're transporting the dust away, where your dust collector is, do you have explosion venting on the collector, etc. Have you put it outside where it can explode and not damage anything, or is it sitting in the back of your factory potentially ready to go off and spread fires inside? Key thing with combustible dust is maintaining the equipment and also looking for fugitive dust accumulations. In most dust explosions, if you get onto YouTube and have a look at flour silos or wheat silos are a great one. They always go bang at some point in their life. Dust explosions tend not to be a single explosion. They usually have a minor puff at the start and the pressure wave from there dislodges fugitive dust that's sitting on your roof beams, piled up the walls on top of electrical cabinets. When the first one goes, it kicks all of that dust up into a massive dust cloud, and it's usually the second and third ones that take the walls and the roof off. Housekeeping is the key. And housekeeping by vacuuming or hosing is good. Blowing it around with compressed air is never a really good thing because dispersion is one of the key things about dust explosion. Mixing it up in the air into a fine mixture is when it goes bang. So for anyone, and this is not necessarily printing focused, anyone that creates dust in their industry, try to hose it down or vacuum it off. Don't blow it around because you're getting closer and closer to a dust explosion. Flammable liquids, it's part of the process, it's part of the industry. As an insurance company, we know that you can't very well turn up and say the best way to reduce risk at your facility is to stop using flammable liquids. Makes it a little bit difficult to do most of what you do. So it's just understanding that they're there and looking at how you store them, how you use them, how you dispose of them. Rags is a key exposure in this area, wiping up leftover drips and drabs, and where do you put the rags, where do they sit overnight. Spontaneous ignition is a big loss driver in any industry that uses rags to wipe up solvents, and where you put them. And I've certainly been to a couple of losses where that's been the cause of fires that have caused a lot of damage. Shielded areas is another key one. So over your printing press, for those people that have looked up, you'll see these things up here, like you have on the roof, fire sprinklers that sit up there, and are there ready to fight a fire if one should occur. Most printing presses, given the size they are, they're usually a couple of stories high, and there's a lot of room, and you need to have platforms and the like for the operators to get around and do what they have to do. These platforms tend to shield the sprinkler water from getting to where the fires usually are, which is somewhere in a press tower. So understanding that, having a look around, and at times, and we do this for many of our clients, is we go around and say, well, this particular area, the fire sprinklers are shielded from where the fire is likely to start, and then we have to look at putting additional sprinklers under those platforms so that we have water where it needs to be. As you can see, our very clever presentations department have got a little fire starting down the bottom there. We have our roof sprinkler going off, and it's doing absolutely nothing to that fire. Fires like that, the good thing about the sprinkler going off is it calls the fire department. The only problem is that fire's not being addressed by anything until somebody gets there with a hose to deal with it. I guess the other good, fire sprinklers tend to run about 160 litres a minute out of there. Once you get your fire guys in with their big hoses, they're using about 600 litres a minute per hose. So they tend to spread a whole lot more water around than a fire sprinkler does. So you're much better off having these addressing the fire than waiting for the fire department to turn up. So operating conditions, mainly housekeeping things around the towers. You have ink mist, paper dust, combustible accumulations, all that stuff burns if you put fire to it. Regular housekeeping again is the key, getting in there and cleaning the deposits off, making sure it's not building up. Aside from causing potential maintenance issues, if you do have a fire under there, it's adding to the combustible load. It's just something that doesn't need to be there. Material handling, big rolls of paper, they're heavy. Aside from the occasional bumps that you get with the errant forklifts and the like, the storage of rolled paper is a key, as we'll see soon. How you store it, what sort of fire protection there is key. Ignition source control, that's all well and good having all these fire sprinklers in. Yes, they designed properly, they will control a fire. The key thing is not to have one start in the first place, so that's where we're looking at controlling ignition sources. Typically within the machines you're looking at overheating bearings, static electricity build-ups, hot work, electrical faults and the like. Arson is also a good ignition source. There are people out there that set fires. We certainly pay for a lot of damage that arsonists cause, so it's worth, it is one that we look for and we try to identify ways to avoid that. Smoking's another good one, but legislation's pretty much ruled that out of most facilities now. Something else we look at, a lost driver, is equipment breakdown. Not quite sure, maybe that's a dust explosion happening there on the folder. It's just understanding, is there, in your large facility you've got lots of bits of equipment, but do they all run through one particular bit of kit? Do you only have one folder that can do what you need it to do on a daily basis? What if something happens to that? Just again, having a look through what you're using. Are you relying on a particular bottleneck piece of equipment? If you are, understand about the equipment. Do you have enough spare parts to get it running again? Does Ferrag have a spare one in the country? Can you borrow one from another plant, from one of your competitors sometimes, a gentleman's agreement you can have? It's really just understanding where your exposures are and having a plan in place for what you do if you have a particular incident on that equipment and it's not available for you. So one thing FM Global has done, we're often at the front of changing technologies, definitions and loss protection standards. We've moved away from classification of flammable and combustible liquids. We've found that definition is a little bit confusing, particularly on the side of combustible liquids. It can lead to a false sense of security when it comes to handling these materials. We call everything that has a flash point that can be ignited as an ignitable liquid now. Consider them as liquids that burn. The likes of acetone, isopropyl alcohol and those things, and petroleum is a good example. Those things start at room temperature. Put a match to it and it's on fire. Some of the lubricating oils and the higher flash point materials, diesel is a reasonable example. It doesn't, you can put a match to it at room temperature and it won't ignite. It's not as volatile. However, once you have a fire in your facility, it doesn't really matter what is in there. At some point you're going to get it to the temperature where it becomes a problem. And you may as well have just had acetone in there starting straight away. So it's understanding here, if it's got a flash point and it burns, it's a potential exposure, and it's recognising that and addressing the risk before you end up with a fire that has it involved. A couple of good examples here. So we'll start the video just in a minute, but what we see a lot of now is the plastic intermediate bulk containers, IBCs. They're quite popular now. They're a good size for transporting things around. They're a lot easier to get deliveries in than 200 litre drums. The design, as I learnt recently, is they're typically single-use items, so they're not generally designed to sit there and dispense from and be refilled over and over again. They're designed to change over. The key thing we'd say here, and it's something to discuss with the suppliers or think about how you're handling your supply chain, do you really need to use plastic IBCs? If we can just start that video there, please. So this is a test that was done in the United Kingdom. It's got 800 litres of diesel. Good thing about diesel is the flash point is 72 degrees Celsius, which is very close to the flash point of most blanket wash liquids that are used in the industry. It's a very realistic scenario. A cigarette butt on a pallet is enough to create this sort of fire around the tap. And about a minute after, you can see the diesel starting to drip out from under the tap. The other thing to note, look at the bund it's sitting on. Most people have those plastic pallet buns. So yeah, that's perfect. That's going to catch everything that I have coming out of these containers. If you've got a leaky tap, sure, that's going to make a difference. But once you get a fire involved, we'll see what happens. So that's after 2 minutes. We have a lot of diesel coming out. And very shortly out of the right side of the container, we get a major, there it is. So that bunding tray is pretty much useless now. That's doing nothing for us. And we've got 800 litres of diesel coming out. Yes, it has a high flash point, but as I said before, once you've got a high flash point liquid involved in a fire, you get this. Thankfully, they did that just outside. But I'd be pretty sure most people don't store these outside when they're using them, because that's not where you need it. You need them inside. So typically in these ignitable liquid storage areas, if you have large IBCs and lots of them, you're not just going to burn one of them, you're going to set fire to all of them. And these sort of fires aren't ones you can put out with sprinklers or hoses. They're typically ones that people stand back and let burn out, and they'll contain them. Something to think about. So we've got, so I hear you say, well, I have high flash point material. So I've got lubricating oils, 160, 180 degrees Celsius, high flash point oils, mineral spirits. Got a lot of these responses, so we thought, all right, we better have a look at these. So we, believe it or not, we bought some and we set fire to it. So what we have here are 2 pallets of small plastic bottles full of mineral spirit in cardboard boxes sitting in our test facility. Just before we start this one, just to make sure everyone's awake here, what's a typical fire department response time? What would you think? How long before a fire alarm starts that you think the red truck appears at the gate? 3.5? Yeah? 10 minutes. So that's at the gate. How long do you reckon it takes them to roll the hoses out, make sure everyone's out of the building and get some water on the fire when they know where it is? 180 seconds. All right. I'd like to know where your fire department is. Yeah? That's good. Maybe they're next door. Some of them, and if they know your facility and they know you've got a lot of bad stuff, they will turn up pretty quick. 5 to 10 minutes is usually good. Typically, looking at the loss data, it takes them about 20 minutes once the fire alarm goes off to get water on a fire. So in those 20 minutes, whatever you've got in place, be them fire sprinklers or nothing, or fire extinguisher, or emergency response crew with a fire hose, that's all you've got responding to these type of things. Good thing, when we do our tests, we always have a clock running, so keep in mind, let's say 1.5 to 5 minutes for them to turn up at the gate. Let's have a look at what happens. Oops, sorry if you can hit that again. No! So this has got fire sprinklers above on the ceiling, and apart from a few water miscible ones like the alcohols, fire sprinklers do very little to address ignitable liquid fires. Just turn that down a bit, it gets a bit annoying with that.
30 seconds, flames about halfway to the top. 40 seconds, flames reach top of pallet load, approximately 5 feet high. 53 seconds, flame 6 feet high. A minute and 15 seconds, flames about 10 feet high, increasing in severity. Minute and 19 seconds, we have some leakage of mineral spirits. Minute and 26 seconds, flames about 15 feet high. Minute and 30 seconds, flames are spreading out under the pallet load in the liquid which is on the floor.
The fire department don't
Minute
get
and
called
38
until the
seconds,
sprinkler goes off.
thick grayish smoke is building up. Minute and 40 seconds, we have fire to the east, west, north, and south. Minute and 50 seconds, flames about 20 feet high. Minute and 53 seconds, first sprinkler opens. Minute and
So now the fire brigade have got the fire
now the
call.
sprinkler opens, flames are on the ceiling at the same time.
And then 5 to
2
10
minutes and
away.
5 seconds, radiant heat is quite noticeable, approximately 30 feet from the array. Fire continues to build, 2 minutes and 15 seconds. 2 minutes and 21 seconds, the radiant heat continues to build.
With the 2 minutes and 29 seconds. So the fire brigade got their call. Unless you have smoke detectors, and a lot of people do that call the fire department, the thing that calls the fire brigade in a sprinkler facility without detection, which typically your ignitable liquid rooms don't have, is when a fire sprinkler goes off, there's a water flow alarm on your sprinkler valve set, and that water flow alarm is what calls the fire department. So you need a sprinkler to go off to get your fire department call, provided nobody sees that. And if you're in a storage area and no one's around, then no one will see it until the alarm goes off. Pretty impressive. It's worth noting at our test centre they do have very well trained firefighters, and they actually stand out in fireproof suits. Looks like they're volcanologists going to get lava samples, but they stand there with hoses. There's about 4 or 6 of them there with a hose on each side, in contact, and if they can see that a fire test is getting out of hand, then the test is aborted. It's called a fail, and they get in there with the appropriate equipment and put things out quick smart. We haven't burned our test centre down yet. It's come pretty close a couple of times, but we don't really want to burn it down. It costs too much money to make. Okay. So that was a high flash point. What would be classified as a combustible liquid per most of the local standards in this region. So the other thing to watch is handling and dispensing of ignitable liquids. This is in the rooms where you're mixing, you're draining stuff out to take out onto the press, you wash materials and the like. How you're handling that. A key thing here, whenever you're flowing a liquid through a pipe, you create static electricity. So bonding and grounding is a key thing, making sure you've got zero electrical potential between the bits you're taking from, the bits you're carrying in. Safety bungs, basically vents on the cans when you do pull the vent cap off so you can actually get liquid out of the can, is putting a proper safety bung on so that if there is a fire in there, it relieves the pressure appropriately. It doesn't allow fire to get back into the drum, where you get these drums rocketing off through the facility. And typically in fire events, if you see drums and stuff rocketing away, they haven't got any pressure relieving on the drum. The fire department tend to move back quite a way. They won't stand there and do anything for your facility if there's 40 and 200 litre drums shooting around the place. Fire protection, again, as I said before, other than the alcohol type of ignitable liquids, fire protection does little to put these fires out. They've got to burn themselves out. So fire protection is really there to keep the building around it standing up. So it keeps the roof cool so the roof doesn't collapse, keeps the walls cool so they don't fall down, and it basically just protects that cell while the fire does its thing and burns out. In mind, containment and drainage is good, so you want to make sure these things are contained in a room. I know I've been out to the Ellerslie site there. Ignitable liquids dispensing room has the ramps and drains and stuff, so if you do have something go on in there, it stays in the room where you want it. You don't want it spreading out into your press hall or wherever else your room's attached to, because then it creates big problems. We had a good example from a recent client. They had a facility in Victoria. They had this very type of room set up. Operator error. And I guess that's one thing to consider. Operator error is a key source of incidents, whether they're up late watching the State of Origin or they're having personal problems at home. All sorts of things can affect someone's judgment when they're working on a facility. Some people just have a bad day and you make mistakes and things happen. So they had an incident like this where a fire started in the dispensing room. Thankfully, it was adequately designed. There was adequate containment. Their sprinklers were fine. They evacuated the site. The fire was contained in that room by one sprinkler, and the site was down for about a day and a half while they did clean-up operations. Conversely, the same company had a large facility in Scotland, and you'll note I said had. Very similar situation, but inadequate protection, inadequate controls, and that site burnt to the ground from the same incident. So it's just about recognising the exposures that are there and making sure you're doing the best things you can to prevent them from getting out of hand. And that was about $160 million worth of facility that's not there anymore. These things get expensive. So roll paper storage. So we've just seen how much work it takes Steve and his team to make these rolls of paper. Who thinks they're a fire hazard when you've got them sitting in your roll paper store? Steve knows they're a fire hazard. Thank you. Does everyone agree they're a fire hazard? Yep. The grade of paper makes little difference. We're using the mid-40 paperweight here for the newsprint. You can get all the way up. I've into a facility recently that were making over 400 GSM carton board for tissue boxes and the like. It doesn't really matter what rate the paper is, it all burns in a very similar fashion. If we can start the video here. So this video here, again, is a test where the sprinkler system hasn't been designed appropriately. Come on. We tested this yesterday. Yep. All right. Just Go! Hang on. Just a minute.
24 seconds, 9 feet high.
We're lacking the picture, that's all.
12 feet high, 28 at the top of the array.
Talk about static electricity being a source of combustion.
Yes.
How would you classify cell phones?
Oh, gee, that's I would when I walk into a ignitable liquids room. Yep. And whether, I don't know, yeah, you can see, I've obviously read a few things about it, and there's conjecture as to whether it is a problem or not, but often just the process of dragging it out of your pocket is enough to create the static spark. So whether the cell phones aren't intrinsically safe, so if it does ring, I'm sure somewhere within that cell phone there's a little contact that might not be there and it creates a spark. Whether there's enough ignitable liquid in there or vapour in there to start something, I'm not sure, but I think I watched a YouTube video of somebody who set fire to themselves at the petrol bowser, and they think they concluded it was more the static of dragging the phone out of their pocket that started the fire than the phone itself. So, yeah. Can we? All right, there we go.
24 seconds, 9 feet high. 26. 12 feet high. 28 at the top of the array. 31 seconds. Flames across the ceiling. 37 seconds, flames across the ceiling, approximately 25-foot diameter. 42 seconds, the first sprinkler operates. Minute and 36 seconds, paper is exfoliating from the ignition stacks. Minute and 42 seconds, there's a large quantity of ash being driven to the floor by the sprinkler water. Minute and 52 seconds, the south target stacks are steaming. 4 minutes and 21 seconds, the flames are approximately 25 feet in diameter across the ceiling. 4 minutes and 27 seconds, more sprinklers are operating. 4 minutes and 31 seconds, the south target is completely involved on all faces, from the 6-foot level to the top of the stack.
Okay. So that was less than 5 minutes. The first sprinkler went off at about 37 seconds, I think. So as that video ended with that large inferno, if you're lucky, your fire truck's turning up at security and asking where the problem is. Typically, as you saw, within 30 seconds there was a jet-like flame pushing at the ceiling. If you've got a metal ceiling, the fire brigade will see where the fire is because it usually burns a hole straight through the ceiling. These type of fires, the heat release rate is incredible in the megawatt range. The ceiling temperatures they measure at the test facility.
We have ignition.
It's off again. They measure the ceiling temperatures. Within about a minute and a half, you're sitting at a temperature where the structural steel starts to weaken. So typically, by the time the fire brigade's there, the roof's starting to come in. Attached to the ceiling is your fire sprinkler system, and once the roof comes down, the sprinklers come down, and it's all over. So you've just got your 6-inch cross main on your sprinkler system sitting there, open, and all the water's out. So given most of the fire systems on site are hooked together, once you let a 6-inch pipe open freely, there tends not to be enough water around to use your fire hoses and other sprinkler systems. So typically the fire department aren't going to do a whole lot for you. They'll work out where it is, they'll try and find out where they can contain it to, and then they're just going to stand back and let it go. Which can be a problem if your roll paper store's attached to your press hall or other parts of your facility. Tends to be a bit troublesome for business for a while. And the key thing is, and what we learned from our fire tests, is that not all sprinkler systems are designed adequately. And believe it or not, we see this quite regularly when we go out to facilities and we have a look at their systems. Our engineers, we have a software program where we model the sprinkler system and we work out what sort of water you can get out of it, and we present our clients with advice sometimes, and we certainly see plenty of roll paper stores that don't have enough fire sprinklers in them that are going to end up this way, and there's some very, very well designed ones that are going to manage quite nicely. So if we move to the next slide, here's an example of a sprinkler system that does work properly. Just iron out our technical bugs again.
We have ignition. 30 seconds, flames at least 15 feet high, and now quickly topping the top of the array. 36 seconds. 38 seconds, flames are on the ceiling overall 30 feet high. Radiant heat is noticeable. 45 seconds, flames in the ceiling is 10 feet diameters, and at least 2 or 3 sprinklers have opened. 50 seconds, flames still steady at the ceiling, extending 10 to 15 feet in diameter. 1 minute, additional sprinklers have opened. Flames at the ceiling, still 10 to 15 feet in diameter. At least 6 sprinklers have opened. 110, fire now approaching the south face of the stacks and spreading up the south face. 117, additional sprinklers have opened, probably 8 to 10. 123, very little change in the fire. Fire appears to be now spreading northward. Still has been no fire spread into the flue to the east of the center ignition row.
So there we finished, that video finished at 7 minutes. So if you've got things addressed in 7 minutes, then you pretty much got it contained. If you're going to lose a fire, then it's generally in the first 5 minutes is when it gets past the capabilities of fire protection systems. So fire systems, most fire systems are designed to contain a fire, keep it in one spot. It uses pre-wetting. So you'll see they spoke a little bit out in the video about the target array. So they emulate a whole warehouse. You want to set fire to a whole roll paper store because it gets expensive. So they have the ignition array where they set the fire, and then they stack material around it called the target array. And the fire test is designed, you've got the sprinkler system has to stop the fire spreading from the ignition array to the target array. And that's considered a pass. Once it crosses the aisleway and starts the other things off, then that's not good enough for us, and we terminate the test. and they'll go and rig up a bigger sprinkler system and start again. And they just keep doing that over and over until they figure out what it takes to put that sort of fire out. One thing of note, these systems are designed based on the storage configuration that the original facility was designed for. So putting an extra row of rolls on top, if there's enough room, can potentially go from having an adequately controlled fire to an inadequately controlled fire. Changing the way you store them, so if you've got them touching in one direction and then you open the array up for something, like if you change the type of forklift you're using and it can no longer store them butted up against each other, that can have an impact on the protection. If you go from metal bands to plastic bands, that has an effect. In the fire that got away, you'll notice they talked about exfoliating paper. Basically, that's how a roll burns. It just burns that layer off and it just keeps unravelling itself and going faster and faster and getting hotter and hotter. So if you have a metal band around it, it doesn't let it do that, and that helps control the fire. If you wrap them or unwrap them, in the robotic wrapping machine Steve showed us, they're wrapping the lightweight paper in a heavyweight paper. I know you guys do that for print quality. It keeps the moisture in there and it makes it easier to work with, but it also does a lot of good things in terms of the fire potential, because a lightweight paper reel burns quite a bit hotter and faster than a heavyweight paper reel. Still end up with a large fire, but it's easier to address a heavyweight paper. So if you wrap lightweight paper in heavyweight, then you can protect it as heavyweight paper, which is good. If for some reason your supplier turns around and says, we're not going to do that anymore, we're going to give you this brand new plastic wrap, it's much better, that can potentially affect your fire protection system. So it's all worth keeping an eye on these things as you go through the process. The one thing I will say is, even though that was a controlled fire, it's still a big fire. It's not exactly something you want to have happening. It creates a lot of mess. Sprinkler water is dirty, it smells. The soot, the one thing sprinklers do is they drive the fire products to the floor because it cools everything down, so you get all your ash and soot coming to the floor, spreads out all over the place, and it makes a right mess. So you can pretty much say most of the paper you have in the same area is going to be unusable, so you've got to trash that. That's what we do. We buy all that as an insurance company. That's part of it. We buy all the crappy stuff and we give you new stuff. But it takes time to replenish the side of your roll paper store. It's good for Norski. They get to sell you a whole bunch more paper and fill your store up again. But it just takes time to do those things. So on that note, you can protect against a fire, but if you can stop it happening in the first place, it's good to do. So we'll have a little bit of a look now at some of the other hazards that you have in facilities. Electrical equipment is a good one. Transformer construction and maintenance. Transformers, you may or may not know, they're just a tank. There's the electrical kit inside, and the oil-filled ones are filled with the dielectric insulating oil, which happens to be a high flash point mineral oil, so it burns. And so you've got a ignitable liquid inside a steel box with an electrical ignition or electrical equipment inside. Not too bad if you maintain it. If things get away, I'll show you in the video shortly. We won't start it just yet. You can see what happens. Circuit breakers, again, how old are they? Are they, from when the facility opened, 40 years ago? Are they oil-filled old clunkers? What sort of maintenance are you doing? How reliable are they? Do you have adequate sparing? Can you get spares anymore? These things become obsolete, and it's the right time to find that out is now rather than after it blows itself out the wall and you've got to replace it and you suddenly find out that you can't and you have to rejig your whole electrical system. Thermographic scanning is good. Keep a lookout for hot spots, loose connections. They are an ignition source that you don't need to have, and they're an avoidable ignition source. Thermographic scanning is also good for bearings and the like, so you can use it for mechanical inspections as well. But if we go back to the transformer, the video I'll show here is a pretty good one. This is a network transformer on a golf course in the US, so it's a big one. These are house-sized transformers. They've got 40 to 50,000 litres of mineral oil in. Typically, in most facilities in the printing industry, you're looking at much smaller units with 2,500 litres of mineral oil in. So the magnitude is a bit less, but the result is very similar. Consider that most of these are inside your facility, inside your electrical rooms. Essentially what happens here, because it's a bit noisy when it happens, is there's an uncleared fault down the line. So the circuit breaker's open and it's running on a fault current which is extremely high. And the same principle as the kettle, you boil your coffee in. If you run a very high current, it creates heat. Inside a container full of liquid, it boils. So all we're doing here is it's not a liquid, it's not full of water, it's full of dielectric insulating oil which has a flash point. So we're boiling the transformer essentially, and if you want to hit that one. Now he calls the rest of the fire trucks. So I'll admit that was a bit bigger than what you're likely to see transformer-wise in your facilities. However, it's still, if you take that down from 40,000 litres to 2,000 litres and put that inside a little room inside your facility, it's still going to create a bit of a problem. So it's worth, and this all relates to maintenance of your electrical system. It's not just the transformer that can fault. If your circuit breakers aren't clearing faults, or if you haven't, the design isn't adequate, if you do some changes at your facility, so you put a brand new piece of equipment in that uses more power or less power, then you need to check that your circuit breaker settings are all correct. They're all going to clear the faults you need to. And then testing again of the transformer fluid, you can have that checked. Dissolved gas in oil testing. It'll tell you if you've got internal breakdowns. There's a lot of science in there, and they can look for particular gases which tell them that the paper on the windings is breaking down and you need to fix it. It's very clever. So we're looking at business resilience again. You can put a lot of fire protection in, you can recognise your risk, but every now and again things go wrong. Human factors is a big thing, as I said. People have a bad day every now and again, and things go wrong. And it's about understanding what it could be and just putting things in place to mitigate that. In particular, on the human factor side, ignition sources. So we're looking at hot work programs. That's a walkie ignition source. They go all over the place. Smoking controls, maintaining the electrical equipment, looking after your ignitable liquids, looking at where you're storing them, how you're using them, how you're transporting them, making sure they're not going to cause you problems. Emergency response plans is a good one. We talk to our clients about emergency response plan, but expanding it from just getting everybody out of the facility, it's having a look at what you can do in those first 5 minutes before a fire gets away to give your facility the best chance at beating what it is that's happening. So a fire in a roll paper incident, as we saw, it only takes about 5 minutes for that to get away. If for some reason someone's been doing maintenance on your fire sprinkler system and happen to have left the valve closed, then you pretty much don't have a sprinkler system there. So you can spend a whole lot of money putting it in, but if the valve's closed or the fire pump doesn't start, then you may as well have not got it there. So it's having people in the emergency response team that are familiar with that equipment, knowing how to open a valve if it's closed, knowing how to start the fire pump if it doesn't start, and in the process of responding to that emergency. Obviously that comes with the caveat of if it's safe to do so. We don't want heroes charging into a burning building to open the sprinkler valve. It's not what we're advocating, but often these bits of equipment are outside the building and far enough away that they can be safely accessed in those first 5 minutes. Because as I said, if it's not addressed in 5 minutes, then it's not going to be addressed. That's going to be a large problem. The other good thing to do is pre-fire planning. Have a chat to your local fire department, see if you can get them to come down and have a look through. Most big industrial facilities, they'll come anyway. It's good for them to know when they get to the gate where the roll paper store is, where your ignitable liquid storage is, where all the big nasty stuff's going to be. You put a big plan together, you roll it up and stick it in that container on the front gate, but if you've got a crew that turn up and know where it is anyway, then you're going to save time. So get them to come out and have a look through your plans, walk them around the facility. One good thing to coax them out that we've found is invite them to use your facility for training. Tell them they can come down and bring the new recruits down and say, why don't you come down and run a drill in our roll paper store? Might be a little bit inconvenient for a little while, but at least then you've got a crew that knows their way around your wallpaper store. Same with anything. Like, again, a lot of this advice doesn't just apply to the printing industry, you can apply it to any industry you like. Physical protection, again, adequately designing your sprinkler systems, understanding what your exposures are and how you're protecting against them. And going back to new construction, if you're doing expansions and the like, try to build things out of material that doesn't burn. It just adds to the problem. It's very convenient that expanded polystyrene panels are nice and cheap and easy to throw up, but they create a hell of a fire risk. So then you've got to design your fire protection systems to address the building fire hazard, not just what's inside the building, and that can sometimes be worse. So have a look at those things. And ultimately, I guess disasters happen, things happen. That's why you buy insurance. If we didn't have disasters, then we wouldn't have it. I wouldn't have a job anyway, and there wouldn't be an insurance industry. But things do happen. In a recent 15-year period, FM and its clients have had over 300 printing industry losses, in excess of about $210 million US. So that sort of, you don't want to be spending that all the time. So that's why we spend the time to understand what the losses are, understand what drives them, and bring that to people's attention to try and help them. There are things you can't insure against, which are worth considering when you're putting a business case together and talking to the number crunchers who say you don't have the budget for it. I guess good examples of things you can't insure against is the negative publicity. You can be guaranteed that your competitor's going to have that on the front page of their paper. Won't be on your paper because you can't print it, but they'll have it on the front page of theirs. There's your market share as well, because they're not going to be very compassionate in leaving your 40% share of the market there for you to get when you get back. They'll gobble that up pretty quick. There's an environmental impact. There's people that are very passionate about that, and that's a lot of stuff into the environment you don't really need to have. And the personal impacts as well, the people that work for you, they've got mortgages and families to support. Sometimes you can insure for income, sometimes you don't. Skilled trades as well, are they going to hang around for 18 months while you rebuild, or are they going to disappear off to the opposition who suddenly has a nice market share to gobble up? So these are things that can't really be insured against, and things that you have to consider as well. I mean, they're life-changing experiences for a business. Some people get back up on their feet, some people just close up and walk away. So it's better if they don't happen. And I guess we put a lot of things on the table this morning. There's a lot of things to consider. You could ask, well, is it all too much? There's a lot of stuff to do. Where do you start? Well, it's an iterative process. We've been working with Dan at it, Ellerslie now for a couple of years, and I'll say we've got everything looking smart out there. The risk report we prepare doesn't have any recommendations on it. So we're talking about fire protection, adequacy, ignitable liquids, human element programs. It's all been sorted out there. So it can be done. It's a lot of work. The other benefit, and in our company we have engineering over here, and the dark side, which is the underwriting side. We do the figuring out what's going to happen. They do the how much it's going to cost and what the premium's worth. We tend not to cross over when it comes to premium costings, but I feel reasonably comfortable saying if you have a facility that's protected to the best it can be versus something that's ready to burn down tomorrow, your insurance premiums are probably going to be quite different. So there can be a saving in that area as well. And that's the benefit of taking the risk mitigation approach. You create a better facility for yourself, you get a cheaper insurance product, but also you're more resilient as a business, and you can keep things up and running. So again, I thank everyone for your time this morning. I'm happy to answer questions. I don't want to hold the program up, so I'll be hanging around for coffee and stuff, but thank you very much for your time.